are going to see the question from signals and systems given in GATE 1990 from the basic concepts here. So here given that the response of an initially relaxed linear constant parameter network to a unit impulse applied at t equals to 0 is 4 into e power minus 2t u of t, then the response of this network to a unit step function will be. So here given the options, here given that, here come to the solution, given that here it is given that for an unit impulse applied at t equals to 0, then the response is given as this. Then the impulse is applied as an input, then the response we can call it as the impulse response, that is represented with h of t, that is given as 4 into e power minus 2t u of t is given. So here we need to find the response of a network to a step function. So we need to find the step response here. We need to find the step response. So coming to the step response, so given that the impulse response here, this is the impulse response. So by knowing the impulse response, so we can easily find the step response of the system, given that the impulse response is obtained by just taking the integration over this impulse response with respect to t over the limits minus infinity to t, we will get the step response here. So by using this expression, by using this concept, we will find the step response that is represented with s of t here. So this is equals to s of t is obtained by taking the integration over minus infinity to t h of t dt. So this is equals to integral. So here given that u of t is there, so the integration becomes 0 to t 4 into e power minus 2t dt. Then this is equals to 4 into the integration of e power minus 2t is e power minus 2t divided by minus 2 over the limits 0 to t here. So by substituting the limits, we will get this is equals to minus 2 of e power minus 2t minus 1. So this is equals to 2 of 1 minus e power minus 2t, and this is applicable for t greater than or equals to 0, nothing but finally the s of t, the step response is equals to 2 into 1 minus e power minus 2t into u of t here. So the answer A is correct here. Simply by applying the integration for this impulse response, we will get the step response.